When was the last time you did something that you regretted soon after? Maybe you recently said yes to something, although you're already completely swamped with work. Maybe you bought something you quickly realized you would never use. Maybe you immediately clicked on that link in that urgent email from Microsoft. But wait, was the email really from Microsoft? We've all received these phishing attempts, right? Or maybe you have invested a significant amount of money in a hyped stock or crypto which subsequently crashed. This leads us to ask, how can we help people avoid these rash decisions? Could it be by developing QIs that make us stop and think? Hello, I'm Leon Reichertz and I'm presenting our paper Extending Chatbots to Probe Users, which I've worked on with Warren Park and Ivan Rogers. The aim of this work was to explore how we could design a QI that tries to help people when they are at risk of making rash decisions, by helping the user in the moment when it matters, being integrated with the ongoing user activity, and intervening by probing the user's thinking. To come back to our previous example of investing decisions, which seemed particularly interesting and in need of such a QI, we were wondering if we could design a probing QI to support investors' decision making. So let's imagine you are an investor and you just logged into your trading or investing platform. You may check how the stocks in your portfolio are performing, and you may also look at other possible stocks you could invest in. You might look through some of the information you have for the different stocks and then decide to invest in a specific one. Or perhaps you decide to sell one of your existing stocks that you currently hold. Now, before you do either of that, a bot may ask you about your rationale, getting you to put your motivation and investment thesis into words and evaluate different aspects related to your decision. So what this bot does is it basically probes your decision making, which is why we call it ProberBot. So what you're seeing here is the actual prototype that we built as part of this research project. It consists of a simulated trading interface with different synthesized companies and stocks, and integrated into it is the ProberBot. So let's have a look at some interactions with the ProberBot in the trading interface. First, the user may look at different information about a stock, such as the valuation metrics or the analyst's ratings, etc. After having considered the different types of information about a stock, the user may decide to invest in it. However, before being able to confirm the trade, the ProberBot asks the user to provide an investment thesis. Once they have done that, they can move on and confirm the intended trade, or they can revise or cancel it. Now, at a later point in the future, the user may decide to sell this stock they have previously invested in. Maybe the stock has not performed as intended, or some recent developments have changed the investor's view on that stock. If the investor decides to sell the stock, the ProberBot comes back and reminds the user of their initial investment thesis. Then it gets the user to re-evaluate to what extent the initial investment thesis still holds in the current situation. After that, the user is asked to provide the reasons for why the initial investment thesis may not apply anymore. Following that, the user can provide an updated investment thesis and is asked to perform further evaluations. As it could be seen in the screen recording, ProberBot uses different interactive elements as part of the dialogues, including text inputs, sliders or scales, as well as multiple choice or yes and no inputs. The idea was to have a variety of interactions and inputs, which also varied depending on the type of questions asked. But on a more general level, what was the rationale behind the design of the ProberBot and the dialogues it provides? As some of you might know, there are countless pitfalls and traps to avoid when investing, no matter if it is in stocks, ETFs, crypto, and so on. For example, you could get emotional, chase trends, react to the media, lose track of your investing goals, which can then lead to rash decisions. These are just a few examples of traps that can negatively affect the performance and returns you get from your investments. Many of these traps are related to cognitive and emotional biases. A great number of these biases have been extensively studied and are also present in many other decisions we make in our everyday lives. We have chosen a few of these biases as a starting point for the design of our dialogues, which we elaborated in an iterative design process, which I will now describe in more detail. We started off by creating dialogues for our selection of biases, which we then evaluated with domain experts. The experts identified two main issues with the initial dialogues we created. Firstly, the phrasing of some questions was considered too pushy. And secondly, some dialogues were considered to be too specific to certain assumed biases. Let me give you an example for both of these points. First, let's have a look at an excerpt from a dialogue that was considered too pushy, in which participants are asked to evaluate why they keep holding a stock in their portfolio. So in the initial phrasing, Probobot said, "That's interesting. Maybe you want to reconsider why you keep holding this stock." Which was then changed to, based on the expert's feedback, "That's interesting. So you are currently holding a stock which you don't believe will recover." As you can see, the revised phrasing is just a statement which the user can think about, rather than suggesting to the user or almost pushing the user to reconsider why they are doing something, as it was the case in the initial phrasing. Now here's an example for a question that was considered too specific to an assumed bias. In the initial phrasing, Probobot said, "Did any recent news item about this stock grab your attention?" Which was then changed to, based on the expert's feedback, "What were the main reasons why you are interested in this stock?" Which could then be answered by the user by choosing from different options or providing their own input. Here we can see that the revised question lets the user think about what made them consider this stock, instead of hinting at a specific bias, as it was initially the case. So taken together, the revised dialogues were phrased in a more open rather than a leading or suggestive way, and in a way that let the user figure out the reasons for why they intend to make a certain decision. We quickly realized how important these two aspects are when designing Probobots in general, also for other use cases or contexts, to make sure that the Probobots only provide cognitive scaffolds for the user to help their thought process, rather than leading them in a certain direction. So how did we evaluate our Probobot? We gave it to experienced stock market investors who had to go to different situations and scenarios in which they had to make different investing decisions. When they were doing so, they had to interact with the context-dependent dialogues that the Probobot provided to them. All of this happened in the trading tool that I mentioned before. The data we collected was what participants said while they were using the tool, as well as in the following in-depth interview. So what did we find? Our findings suggest that Probot can help in the moment when it matters. It can tie into the ongoing activity and thought process, and it can make users stop and think at appropriate times. Let me give you a few example quotes for these. First, let's start with how it can help in the moment when it matters, where participant 6 said, "It made you re-evaluate your thought rather than having a knee-jerk reaction or emotional response." Now here's an example for how it can tie into the ongoing activity and thought process, where one participant said, "It's nice to be reminded of your early decision-making process, because sometimes you forget you've actually done quite a lot of due diligence and thought about something very carefully." And here's an example of how it can make users stop and think at appropriate times, related to which one participant said, "You could interpret the situation for these companies not risky decisions necessarily, but where I needed to stop and think about it." And finally, I would like to highlight another important point that came up several times, which is the dilemma of needing but not wanting the Probobot, which is nicely captured in the following quote. "If I don't want to waste time telling the bot why I want to buy or sell now, then I think I should have the ability to skip it. So maybe this is when the market is moving really quickly. But at the same time, maybe someone else might say, this is exactly when you need it, so you don't overreact." This leads us to 3 key design implications for Probobots and their dialogues, which should be probing users' thinking without leading them in certain ways. Secondly, they should engage the user's thinking, but at the same time they should not be too long and disruptive. And finally, They should be configurable, allowing the users to customize the amount of and the types of probing the ProberBot provides. However, there should also be some constraints to the configurability of ProberBot to avoid that users turn it off when they really need it, which relates again to the dilemma of needing but not wanting ProberBot, which I mentioned before. So finally, how effective are ProberBots? Our findings suggest that they're good at probing users' thinking. Furthermore, they can enable users to externalize their thought processes in a structured way, and by that increase the user's awareness of their thought processes and their decision making. Finally, ProberBots seem promising to slow users down and prevent them from falling into the trap of certain rash decisions.